Let's graph a transformation of the cosine function. First, we'll identify the 5 properties, reading from left to right. Reflection, yes there is. There's a minus sign out in front, so there is a reflection. Amplitude is the absolute value of the leading coefficient. We find the period by looking inside to the leading coefficient of the angle. That needs to be divided into the standard cosine period, which is 2 pi. Phase shift. We can do some division to find the phase shift. We can divide the pi by the 3, or what I prefer to do is to factor the angle. Then we'll see the phase shift directly. Either way works fine. This is how we would factor out 3. Double check, 3 times x, that's 3x. 3 times pi over 3, that's pi. So the phase shift then is the opposite of what we see here. It's the angle that shows up after the minus sign. So that's pi over 3. I tend to remember it as the opposite of what we see. We see a minus pi over 3, so the phase shift is pi over 3. Vertical shift is on the outside, down 1. Okay. Now we are going to go to the graph. We have to keep in mind that this is the basic shape for a cosine, and we will apply these 5 characteristics to our transformed function. So let's draw a coordinate system. And we always start at the phase shift. And it doesn't matter where we put it, just get it on the graph. So I'm just going to put it right there. Phase shift, pi over 3. Next step, we look at the period. The period tells us how far to the right we need to go to complete one cycle of this cosine function. So we're going to add 2 pi over 3 to pi over 3. That's 3 pi over 3, which is pi. So let's see if I can get that in there. There's 1 pi over 3, 2 pi over 3, 3 pi over 3, which is pi. All right. We can now look at our vertical shift. That's the 3rd step. And that creates our center line. And our center line will be at -1 between pi over 3 and pi. So our graph is going to be centered around that gray line there. The next thing we do is take a look at the amplitude. The amplitude is going to tell us how far above and below the center line we go. That's 2 units, so we're going to go above 2 units and below 2 units. We now look at the shape of our graph. There's our shape. And we have to combine these 5 key points with this reflection. There is a reflection. So that comes into play now as we plot our 5 key points. Remember that our center line for this shape, the center line is right in there. So the 2 points on the center line, because of the reflection, those aren't going to move. Those will still be where those will not be affected by the reflection. So let's go ahead and start though. Let's graph these 2 upper points. So those 2 upper points would normally be 2 units above at the left and the right endpoints of the first period. But because of the reflection, we are going to put those 2 points down. The center point is normally down below the center line, but because of the reflection, it's above the center line in the middle. So right there, 2 units above. And then we go to our quarter points in here, and we will have those 2 points on the graph also. We can now connect the dots with a nice smooth curve. And that is the graph of our transformed cosine function. And it will go on forever to the right and to the left, repeating itself. We don't need to put those in. We don't need to put arrows, but if you want, you can. It's up to you. Let's finish this off by finding the domain of this function and the range of this function. Well, this function's domain will be all real numbers. There are no real numbers for which there is not a point on the graph. So the domain is all reals. Or if you wanted to write it in interval notation, you would write it like this. And the range of this function, that's the set of y values that it has. The set of y values starts down here at -3 and goes up here to 1. And we put brackets to include those endpoints. There you have it.